Have you ever just, stopped and really looked at a glass of water? It seems so simple, so ordinary. But what if I told you that inside that very glass is a story that stretches back billions of years? A story full of scientific paradoxes and mysteries that, honestly, still have scientists scratching their heads. So let's dive in and uncover what's really going on in there. I want you to really think about this for a second. That sip of water you just took? What if those exact same molecules once flowed in a river that a T-Rex drank from? It sounds like something straight out of a movie, right? But it's the absolute astonishing reality of the water on our planet.
So, to understand how this is even possible, we need to take a little trip back in time. We're going to trace the unbelievable history that's packed into every single drop.
See, the water on Earth is ancient. We're talking billions of years old. Most of it hitched a ride here on icy comets and has been here ever since, stuck in a constant loop. It flowed in primordial oceans, it was part of the rain that fell on dinosaurs, and today, those very same molecules are sitting in your glass. You are, quite literally, drinking history.
Now, all this ancient, recycled water covers our planet. I mean, we've all seen the pictures from space. Earth is this beautiful blue marble. But that image creates a huge, fascinating paradox. We live on a water world, yet fresh, usable water is one of the rarest, most precious resources we have.
The numbers here are just staggering. A whopping 97.5% of all the water on our planet is saltwater. Great for the oceans, totally useless for us to drink or grow crops with. That leaves this tiny, tiny sliver, just 2.5%, as freshwater. And believe me, the story gets even more dramatic from there. Okay, so let's zoom in on that tiny 2.5% slice of freshwater. The truth is, most of it isn't even available to us. Look at this. Almost 70% of it is locked away as ice in glaciers and polar ice caps. Another 30% is hidden deep underground. So the water we actually see and use, the stuff in our lakes and rivers, that accounts for just over 1% of the original 2.5%. So when you do all the math, when you calculate what's actually liquid and accessible for all of humanity to use, the number you get is just mind-bogglingly small, 0.007%. Let that number just sink in for a minute. It's a really powerful reminder of how incredibly finite this resource truly is. All right, so now that we know where the water is, and more importantly, where it isn't, let's zoom in one more time. Let's look at why it's such a bizarre and miraculous substance to begin with. You see, water doesn't really play by the normal rules of chemistry, and its weirdness is the very reason life as we know it can even exist. Okay, here's one of water's biggest quirks. For almost every other substance out there, when it freezes, it gets denser, and it sinks. But not water. Oh no. When water freezes, its molecules arrange themselves into this open crystal ring structure. It actually takes up more space, making ice about 9% less dense than the liquid water around it. And that's why ice floats. That one simple property is absolutely vital. It keeps our lakes and oceans from freezing solid from the bottom up, which protects all the life swimming around in them.
And the weirdness definitely doesn't stop there. Get this. There is a proven phenomenon called the Mpemba effect, where under the right conditions, hot water can actually freeze faster than cold water. It's true. Scientists have some theories, but the exact physics are still being debated. How amazing is that? Even something as simple as making ice cubes holds a genuine scientific mystery. Another one of water's superpowers, its ability to dissolve things. I mean, they call it the universal solvent for a reason. Its unique chemistry lets it pull apart more substances than any other liquid on the planet, from the salt in the sea to the sugar in your coffee. And this is fundamental for carrying nutrients in our blood and inside every living thing.
And just to add another line to its impressive resume, water is the only common substance we find naturally all over Earth in all 3 states at once. We've got solid ice at the poles, liquid oceans, and water vapor as a gas in the air around us. That physical versatility is totally unique, and it's what drives our planet's entire weather and climate system. So we've gone from the cosmic to the planetary, from chemistry to physics.
Now let's zoom all the way down to the microscopic level. That same drop of water we started with, if you scooped it from the ocean, it's not just H2O. It's a bustling, thriving ecosystem, teeming with millions of living things. It's literally a universe in a single drop. So let's wrap our heads around this. We've seen that water is ancient, it's incredibly scarce, and it's a total chemical weirdo that breaks all the rules for our benefit. We've seen that a single drop of it can be a universe of life. So I'll just leave you with this to think about. If one drop is a universe, what does that make the entire ocean?